Hello, JupyterCon 2020. My name is Brendan. I go by B5 on the internet, and today I'd like to tell you about Query. Query is an open source tool for managing datasets. And while it does a number of things, today I'd like to just focus on one flow, which is just getting datasets from Query into your Jupyter notebook using the Python client. Getting datasets into a notebook is a constant challenge. And with Query, ideally, you'll have one extra tool to be able to find, acquire, and explore new data. And so with that, I think the easiest thing to do is just jump right in. In order to use Query, we need the actual Query binary on our local computer. And to do that, we're going to use three terminal commands. The first is going to download the binary itself. Then we'll set up and sign up for an account on query.cloud. So the first command is fairly straightforward. We list it right on the front of our website, which is curl install query. So when I hit enter on this, what's going to happen is Query is going to go to the web and actually download, well, not Query, curl is going to go to the web, download the install, and run an installer script for us. This script is a publicly auditable script if you'd like to know what it's doing, but it's going to do its best to put the query binary on your machine. Cool. Now the query is installed, we can type query help just to prove that it's there. Hey, and look, these are all the commands. Great. Now, before we can do anything else, we actually need to set query up. And that command is fairly straightforward. We type query and say setup and hit enter. And this is going to ask us to choose a username. And this will be your username exactly as it would be on GitHub or any other service where you're actually going to pick something sort of useful and wonderful. So I'm going to call us Jupyter. I'm going to call this Jupyter 2020, and I'm going to hit enter. Great. Now we have a local repository set up that we can pull datasets down to. And the last thing we need to be able to do is authenticate to Query Cloud, which is the most common source of datasets. With Query, it's actually possible to pull data from a number of places, including peer-to-peer networks, other places that you've set up on your own. But the easiest and most straightforward way is with query.cloud, a service that we've set up. And for that, we need an account. And so for that, there's actually a command we can just run from the command line to sign up for an account. And that is query registry signup. And query registry signup takes two things that you have to give it. You have to give it a username, which is just your username from before, and an email. So by signing that up, it's going to now ask us for a password. This is the password that we can actually use to sign into query.cloud. And so for this, I'm going to give it something super secret and not tell you what it is at all. And hit enter. And there we go. What's happened is we've actually now connected our local account to the query.cloud account, and we can use Query to actually pull down datasets. Okay, this concludes the terminal portion of the video. And ideally, we can now just move to doing everything in the notebook itself. And the first thing we're going to do in the notebook is actually pip install query. Once you've run pip install query, congratulations, you're all set up. That's literally all there was to it. The qri-python client is going to talk to the query binary in the background and use it to do whatever we need to do as we're working with the notebook. I'm going to start with some basic import statements. Obviously query because we're going to work with it, but we're also going to import pandas and plotly just so that we can plot stuff and work with data frames. So with that, let's cut to the chase. Let's get a data set. With query, it's as simple as query.get the thing you want to get. And we refer to datasets by a reference, which is simply the username that you're trying to grab from and the name of the dataset joined by a slash. This is a convention you'll see in a number of other services, and we tried to keep this as familiar as possible. If you refer to a dataset that you don't have, Query is going to automatically pull down the latest version for you, but only the latest version. And from there, whenever you refer to that dataset again, it will just load that dataset locally. So you're only making one network request to download things, and things should really speed up from there. And the nice thing is whenever you need to update that dataset, you can use query.pull, which will pull you the latest version. Again, we're trying to sort of layer on top of existing and common conventions. If you've ever worked with Git, pull should seem fairly familiar. And so from here, we can actually shift enter on this cell and show that Query actually is doing some of the common things that you would expect for a tight Jupyter Notebook integration, presenting HTML representations of the dataset itself. And so in this case, you're getting the title and the description from the meta section of a dataset. Let's just get straight to the chase and look at a data frame. So the body of a dataset is a data frame. Every dataset in Query is a single table. And this is an important design choice. We think if you're going to publish data, it's important to format it for easy consumption. Most of us are used to thinking in data frames, and so it's really helpful to have every dataset just be a data frame. This does mean that some things can be a little harder to format, but that design choice and decision can make it easier to get in and out of datasets. And that's really the goal here, is to make everything as comparable as possible. And so we've supported that with additional components beyond the body that make a dataset easier to understand and interpret. The most obvious one is called a Readme. And here I can show you a Readme from query.cloud, which represents a lot of this stuff just on the web for you. Readme is exactly what you'd expect it to be if you're coming from source code. It's a markdown formatted document. And here we're just getting a nice plain human-to-human description of what the dataset is, what it does, caveats, whatever the author intends to show you. We include other components though too for sort of better machine-to-machine interpretation, like a meta component, which includes standard structured metadata based on the DCAT specification, which is a data catalog spec. And this means that stuff like description and keywords and title are all in the same place. And that makes stuff like making datasets machine comparable a lot easier. And so for this example, I can actually just list my local datasets and start to pull out details from them that are all structured the same way. And this easy comparison means that you lose cognitive overhead when you're trying to understand a dataset. Once you learn the shape of query datasets, it's really easy to get into and out of them. And to show you just how comparable these things are, we can actually use qri-python to list our local datasets and pull them into a data frame of datasets. This is already getting a little bit meta, but it's nice to know that it's possible, right? Here I'm showing the actual dataset reference and then its title from the meta section and the last update from the commit. Query includes SQL in the box, and we think this is important for making data prep and cleaning and work a lot easier. In Query SQL, you can refer to datasets regularly with these reference strings and pull out pieces of them. So in this example, we're going to grab another dataset called NYC Borough Pop, and then we can look at the body for this. And here we can see that the body has like not everything that I'd like, and most importantly, there's a NYC total row that I'd like to pull out, and I'd like to rename a bunch of these columns. And so of course we could do this with data frames and common manipulation, but another method would be to use SQL. And so in this example, I can actually just run this select statement, which is going to be pulling from this data set, NYC Open Data Archive, and grabbing the borough and renaming a bunch of columns. And this is going to give us an output, which is itself a data frame. So we type query SQL, we get a data frame back. Again, tables. Here's a nice chart of NYC's, New York City's population by borough from 1950 to 2040. So you may be wondering, where are these data sets coming from? And the answer is viewers like you. All kinds of people are publishing data on Query, and we've tried to include as many tools as possible to make the data being published auditable by the people who want to use it. That's why Query fundamentally is versioned. That's why Query has all of these sort of shapes that make everything similar and easy to interpret. And I think the easiest way is to just show you some of these data sets that people are publishing. There are really two ways to do this, and normally you spend a lot of time browsing query.cloud to find data. Its search interface makes it a lot easier to understand what's there, and we're constantly trying to improve the browse experience of query datasets on cloud. But once you see something you like on query.cloud, it's as simple as going to the top of the page, copying this reference string, moving back to Jupyter Notebook, and inserting a cell under my lovely datasets tab, typing query.get, and the name of the reference. And this process is kind of wash, rinse, repeat. And so with that, I can give you a quick tour of some of the stuff that's available on Query, just to pique your interest and see what's there. The first one I'd like to start with is stuff that we're putting out as part of the Query team that makes it a little easier to sort of work with census data. And if you've ever worked with US Census data, there are a lot of caveats and tricks, and we've really tried to go to great lengths of sort of explaining and showing our methodology for extracting some of these things and presenting tables that are a little easier to process. And so here we can actually use the structure command, which will show you another component of Query that helps understand what's inside of a data set. With a data frame, you often get just the sort of column header and are relying on some external information for understanding what that actual column is about. With Query, we include additional spots where authors of data sets can annotate that data with additional information. The structure is one of the classics. And so we have a schema here, which is going to show us a whole bunch of stuff, but most importantly is including the actual ACS, or American Community Surveys, column name identifier that it was being pulled from, and a more detailed description from the description column. All of this is presented to us in a nice big HTML table. And as we can see, there are lots of columns in the ACS survey. The next one that I like is from Paul Crickard. He published a City of Albuquerque's e-scooter data. If we look at the README for this data set contains City of Albuquerque e-scooter data. This program is no longer operating. The data is only available on Query, and the city does not release the data. I had to jump through hoops and months of waiting to get my hands on it. Sounds interesting. Well, now that it's there, we can get it and we can look at it. Let's do a histogram of the duration of scooter riding in Albuquerque. And here we have, wow. We have almost 800 rides that were 6 minutes and 37 seconds in duration. That's kind of surprising. And then we had a couple of rides that were 2 hours and 18 minutes. Wow. Next up is a dataset query of Twitter bots. This is an incomplete list of Twitter trolls verified by Bot Sentinel, and it's updated weekly. So let's pull it down and work with it. Here's Twitter bots. Here's the head of it. Ooh, probably not merchant. It's definitely a troll bot. Its troll score is 0.87, and it joined in 2015. Okay, cool. Scatterplot time. And this is unsurprising. The ratio of followers to following sort of huddles down in the bottom left, pretty close to 0. Let's move on to another one. This is a personal project that I've been working on. I've been trying to study the intersection of open source and cryptocurrency. I think that because cryptocurrencies are kind of all the same type of thing, their open source projects should have some sort of trends or patterns in the way that they emerge. And so for that, we can pull down this data set, look at it, and let's get straight to a graph of the language that each project is presented on in GitHub. And this to me was kind of surprising. I didn't realize just how popular C++ was as a language in cryptocurrencies. And this actually explores the entries and exits to the New York City subway system, which is originally presented as raw turnstile data, but in this case is actually being re-aggregated up to stations, which is actually what you want to see, how many people entered and exited a specific station. And here we have the structure of the data set. Let's look at the head of it. Cool. Let's do a quick plot of entries and exits by date and stop name. Wow. Interesting. Times Square had a nice bump on May 4th. So that's a 0 to getting data tour of query in Jupyter Notebooks. Hopefully this has gotten you excited to pull down a dataset, and if we're lucky, even publish a dataset of your own. If you are, we have lots of tutorials on how to do that with the command line client, and in the future, you'll be able to do that directly from inside a notebook. But from here, if you're interested in what we're doing as a project, Query is totally open source, and everything you saw today is free to use. Good luck with playing with data, and hopefully you have a great JupyterCon. Thanks so much.